Okay, so we're back in here for day 2 of the burner lab. As you can see, I've set up 4 ring stands, the 4 heights that we talked about yesterday. Really, really low at the bottom of the burner, right at the top of the inner flame, right at the top of the outer flame. And it's a little hard to see the outer flame, but it's right at the top. And this one's about this much above the top of the outer flame. I'm gonna start the timer, put them under, and let the heating begin, and we'll just see which one does best. Start here. And there we go, all overheating. Started with every one of them, had the exact same amount of water. I measured it in a graduated cylinder, exactly 250 milliliters. Put a thermometer in each. They all started out at 22 degrees Celsius. And so now we'll just wait and see. While it's heating, make a few little comments about the pre-lab. Got some really interesting answers about independent and dependent variables. So I'm gonna post another video about independent and dependent variables, make sure everyone understands. Some people put that one of the variables in the lab was the type of gas we use. Well, we're using the same type of gas across the board, so that would be a control, not a variable. That's something that's controlled. The independent variable is the thing that you manipulate in the experiment. So in this case, the independent variable is the heights, or the distance off of the burner, the 4 settings. And the dependent variable can be thought of a couple different ways. For us, we're measuring how long it takes for the water to heat. So technically, that would be our dependent variable. But in this case, you can also think of the dependent variable as which spot in the flame is the hottest. So a couple different ways you can look at that. We're gonna let this go for a few minutes. I'm gonna keep an eye on the temperatures and make some records just to see how things are going. I'm 2.5 minutes in, and we've already got a pretty clear view of which one is the worst. If you have it too far away from the heat, this has gone up to a total of 26 degrees after 2 minutes and 45 seconds. So this, not a very efficient setup. This setup, top of the blue flame, we're at almost 3 minutes, and we are at just at 30 degrees here. So again, it's a little bit hotter than this, but really, we're only about a degree or 2 off. Now, these two, however, are doing a lot better. This one at 3 minutes is at 56 degrees, but this one is at 70 degrees. So the top of the inner cone is clearly the fastest and most efficient. The best height when you set up a burner to get the hottest flame is going to be at the top of the inner cone. We're going to let this go to see exactly how long it takes, and then we can discuss it again in a moment. Our target temperature was 90 degrees, and set number 2, the height at number 2, reached that at 4 minutes and 30 seconds. So I'm going to turn this one off. And we'll see how the others do, how much longer they take. Okay, 6 minutes and 10 seconds in, and height number 1 has also reached our target temperature of 90 degrees. We're going to shut it down. Okay, folks, we are 8 minutes in, and height number 3 is only up to 47 degrees. And height number 4 is only up to 40 degrees. Typically, again, having run this lab for several years, typically this one will take between 10 and 15 minutes to reach temperature. And this one, if it ever reaches temperature, usually doesn't get there till about 25 minutes. So I'm going to shut this down now, but as you can see, the results of the lab are pretty clear. The best height for a burner for the hottest point is at the inside of the inner cone, is at the top of the inner cone. We have a lab scheduled for the day y'all come back. I'll be posting more information about that tomorrow. Thank you.